All right, so I'm gonna get started. Is there someone in here from Cray? I saw you on Twitter. Brethren. All right, so I'm here to talk to you about a very unusual topic for KubeCon. So first of all, thank you for making the walk over here. Either you really want to be here or you're super lost. So either way, I definitely appreciate it. So I want to get started. So once upon a time, I worked on distributed systems. And I spent about 6 years doing this, working on all kinds of different distributed systems. And if you had asked me a year ago what a mainframe was, there were a few words that marketing doesn't like me to say that would have come to mind. Old, legacy, outdated. They probably have spiders in them. I don't know. So how many of you in here have worked with mainframes? In mainframes in your organization? Yeah, okay. So they were very foreign to me, so I really didn't know what they were. I kind of thought, big old computers, right? So I wanted to tell you a story. When I was working on distributed systems, I was working on OpenStack for a few years, and then working on Apache Mesos, and then drifting into Kubernetes. We would work with customers, and I would talk to community members, and they generally would bring in a new DevOps team. And that would be the people who would come to modernize the platform. So the company would have a mainframe already, but they wanted a new team to come in and make things all shiny and new and use all those whiz-bang features and everything. So they brought in this external team. And the mainframe team would be sequestered off into their own little basement somewhere in a different team. They wouldn't really be talking to this new DevOps team, but they were pretty much separate from the process. And this was very unfortunate. But down the road, we'd be working with them, or I'd see a story at a conference or something. And 18 months later, into their modernization effort, they did a lot of microservicing. They split up their monolith. But in the end, they didn't replace the mainframe. And in some of these talks, especially when I went to ones at MesosCon, they sort of saw this as a failure. They're like, listen, we got to a certain point, but we just couldn't replace the mainframe because it's doing things, you know, we can't take it down, we can't break it up, we don't understand it. And there'd be a whole bunch of reasons why they got to this point. So, I already mentioned a little bit about my background, but I've been doing systems administration for about 15 years. All of that's been on Linux. So, I joined IBM back in April. And this was an interesting conversation with them because they contacted me in like December or so when I was looking for a job. And they're like, hey, Liz, you want to work on mainframes? And I'm like, no. But I talked to some of the engineers, and they actually built a really compelling case around open source and the direction they were going. And I eventually joined on, so I joined the IBM Z team as a developer advocate. I've also written a couple of books. So I've been in the Ubuntu community for years, and I also wrote a book about OpenStack when I was working on that. So definitely my background is like deep distributed systems. So I want to start this out by telling you the things I wish I had known a year ago. So the first thing I thought of when I thought of a mainframe was the one that came out in 1964. But vaguely in my head, I knew they came out a really long time ago. So the first mainframe was the S360. I got to visit one when I went to Poughkeepsie a couple months ago up in New York. They have a whole museum outside of their assembly plant up in the Poughkeepsie IBM office. But that's like sort of what I thought. They're old. But it turns out they're not. IBM releases a new mainframe roughly every 2 years. So that's the one on the other side. We released a new one in September. We had whole big fancy release events. It was pretty cool. But they're much smaller now. But essentially it's a big computer. But they're not as big as they used to be. The one here closer to me, it fits into a 19-inch rack spot. So it uses like standard connections that you get into a data center. And so it's pretty much just like drop it in. The one on the far side there, so this is one that runs z/OS and a bunch of other operating systems. The orange one is the Linux One machine that only runs Linux. And that is an example of a 4-frame model. So it takes like 4 of these 19-inch ones, reconfigures all the bits inside, and in like a fully decked out 4-frame model of one that came out this year, you get 40 terabytes of RAM, a bunch of PCIe control units across like 12 drawers, and these things are huge. I'll show you a picture in a minute. And then you have like 85 logical partitions. These are LPARs. And those are what you actually install the operating system on, and they're like fully hardware isolated. A big thing here is that they're not x86. Depending on who you talk to, the architecture is IBM Z or Z architecture. On Linux, you're most likely to see the term S390X. But they're the fastest commercially available processors. So supercomputers are faster. But these are the ones that you can buy, so 5.2 gigahertz processors. There are like 190 of them in a fully decked out system, and they have 12 cores per chip, which you can sort of see on there. They also have like this really intensive caching system, which makes them pretty fast. Also, since it's not x86, you need to recompile your software to run it on it. This is what the inside of a 4-frame one looks like. This is the air-cooled one. There's also a water-cooled one. But you can see like in the center, it's hard to see. There's like no good color to put on this chart. The middle ones, those are all your processors, and then all your I/O drawers. So that has like your HSMs and like all your connection to storage, because this does not have storage. This is like one big, massive computing machine. Oh yeah, and there's like network and stuff on the top. So this is the storage. This storage unit was released in September alongside the new Z15. This one has almost 6 petabytes of storage, which is a lot. There's like different storage models. Some are like SSD, and some of them are spinning disks. But this one's like the top of the line SSD one with 6 petabytes. It has like its own operating system that manages the disks on this machine. And so traditionally, this is what they run. So ZOS is kind of like the mainframe operating system. If you think of mainframes, that's what you're going to think about. There's also ZVM. That's the virtualization technology that was released in 1972 and has been modernized all through the years. There's a ZVSE, which is like a mini ZOS, which may be for like more entry-level customers. ZPTF is the one that all of your airlines will use, except for Southwest. They're like the one airline that doesn't use mainframes, but all the rest do. So it's for like special purpose for like high volume transactions. And then there's Linux. So Linux has been running on the mainframe for about 20 years. So I'm sure some people just came here to satisfy morbid curiosity, but about half of you said you've actually seen mainframes and have them in your organization. So you have a mainframe, but you want to do all that DevOpsy stuff, right? You want containers, you heard of this thing called Kubernetes, and you want to modernize everything and make everything awesome. So going back to my story, why did the modernization effort embarked on by so many of these organizations stop when they got to the mainframe? Turns out mainframes are really quite nice. This is one of the things that convinced me to come over to IBM. Looking back, if someone had just explained to me that mainframes sit in this space between like racks of x86 hardware and supercomputers, like that would have been a good description for me. But that is where they are. They are really super powerful machines. And one of the things I came to the realization of in these past few years is that when I got into Linux, so I started playing around with Linux like 2001, got my first systems engineering job in 2006. So like at this time, Google had already come into the market and said, everyone, it's great. You can get rid of all your old big machines and just use a whole bunch of x86 hardware. They're cheap and they break all the time, but they're really cheap, so we can just string them all together. And so this is what I grew up in as a systems administrator, and that's kind of what I thought the whole world was. But now I'm looking at mainframes and things, and I'm like, actually, there's really good hardware out there that a lot of people are just ignoring, because Google said it's better just to use a lot of cheap stuff. And one of the things that we've also been finding recently is it's no longer cheap stuff. When you talk about the bills that people are getting from big cloud providers, those are really huge bills. And when you look at the cost of a mainframe, which I don't actually know because I don't sell them, but like there have been like cost analysis by independent providers saying that like mainframes actually are cost effective in a lot of instances because they're so big, and people are spending so much on the cloud. So some of the big things about the mainframe though is like there's this like enterprise grade storage is totally a thing. And not to take away from the great projects that are doing distributed storage, like Vitas, which just graduated. There are places for this enterprise, like for these distributed systems for storage to be. And I think it's awesome that this technology is out there, but it's not the answer for everyone. For one, it takes administrative burden. You have to have people who know how to run these distributed systems. And then you have to make sure it doesn't break, because losing data is bad. But mainframes, I mean, like when I look at some of the discussions on the CEF mailing list, it's kind of funny because now that I'm getting familiar with the enterprise grade storage stuff, I will see a white paper from like 1983, and it's like the same discussion as they're having on the CEF mailing list. And I'm like, you guys, this was solved already. You're not gonna solve it over beers tonight. So like enterprise grade storage is a real thing. And so if you want to just drop in a giant box that does your storage and you don't have to worry about it, like a mainframe can attach to one of those. I mentioned the processors are really fast. We like to say that there's 5 nines of uptime. But during the Z15 release, there was like independently verified numbers. They were saying 7 nines, but since that's not really a thing. But like these machines don't go down. There's this video on YouTube. You can look it up. You can just look up earthquake mainframe, and they take a mainframe and they lift it up on the big thing and they shake it and see what falls out. So they're like tested to be like up to like 8.0 earthquakes. So at like Fukushima, when the earthquake and the tsunami hit, there was a mainframe that was still running after that. Like they go into like this destroyed data center and like, oh, the mainframe is still running. Like, I don't know what it was still connected to, but like, there's like stories like this that come out. They don't. Yeah. Yeah, so I've got a colleague from IBM here, and for the recording, he said there's a picture of how it like fell through the floor. Yeah. There's a question here. Yeah. I'm sorry? There's no battery, like, yeah. So, I mean, it's not gonna run everything, but. Other things, so like, one of the other things I've seen in these infrastructure projects where they're going to modernize is networking is a huge pain. Like, you don't really think about it so much when you're doing your plan, but like, the connection between VMs in the mainframe, they're already configured super fast. So you still need to worry about like container networking, but you don't necessarily have to worry about like the VM communication or anything that's on the mainframe itself. So it's got really fast access to the storage, and it's got really fast access to each other without having to go through networking hell to get there. There's hardware-driven crypto, and this is a huge thing. So on the processors, there's crypto co-processors, so it means you can encrypt all of your data, like in flight and on the disk. And one of the industry numbers I got was like only 4% of data is encrypted. So companies tend to decide what they want to encrypt because it's really expensive computationally. But on the mainframe, you don't necessarily have that problem because it's got onboard crypto, and you don't take away from your general processing when you are doing it in the hardware crypto services. So one of my favorite things is that when we ported Golang to this architecture, we actually made it so Golang can access the hardware crypto. So if you're using crypto in Golang on a mainframe on Linux, it's crazy fast. So it's really cool. And the sales guys love talking about the HSM. Like, I don't know, HSM, it's never been impressive to me, but apparently it is the industry's best. If you mess with the hardware security module, like it will just zero itself out and not let you do anything. And of course they run Linux, and they've been running Linux for over 20 years. This is one of the things I didn't really know about. So in 1998, there was a community effort that came out, and they were playing with Linux on the mainframe. Now 1998 is like, I will install Linux on everything era. Like this is when that like essay and book came out, like installing Linux on the dead badger. So like it was just cool and funny to install Linux on everything, and that's kind of where this group came from. Like they had a mainframe and they're like, that would be funny. So like the first few reasons, if you read the history of like when they were doing the effort, were like, they were totally goofy. Like it's gnarly and it's fun. And then they were like, oh, and then there's like actual business reasons. And so the community came out in 1998 with this, and it turns out IBM had already been working with this internally because they were already on the Linux train. Like IBM's been contributing to Linux since the mid-90s. So they were like, oh, I guess we have to tell everyone about this because now the community's like scooping us. So in December of 1999, so almost exactly 20 years ago, IBM came out with the first patches for the Linux kernel. I think it was like a 2.2 kernel. So long time ago. And then in October of 2000, the first version of SUSE Enterprise Linux came out. and it was for the mainframe. And it was called SUSE Enterprise Linux was because it was for the mainframe. Now, there was like lots of rebranding, shuffling and stuff, and eventually they wanted to use Enterprise Linux for all of their things, but that means that SUSE Enterprise Linux is mainframe native, and x86 is the port. It's not really true, but that's the story I'm telling. So the x86 version of SUSE Enterprise Linux came out in 2001. So I say you have to recompile software, and that has been done. There's a ton, so this is just like our glamour slide of like a ton of the projects that have been ported to S390X or Z architecture. So when we talk about running Linux on it, you're running Red Hat, SUSE, or Ubuntu. Some of the community projects have access to mainframes to build it too. So Debian, CentOS, Fedora, they all have builds as well. And what this means is that you can run these distributions. You can like apt-get install whatever you want. But there's like a limited set. So like the packages, if you search, there's like a SUSE search where you can search like how many packages have been compiled for it. So what these projects essentially do is they compile the software, run it through their tests, and if it passes and it looks good, then they ship it. And they're like, all right. So Ubuntu actually has the biggest repository of packages. And then SUSE and Red Hat have pretty big ones too. I think it's like 30 or 40% of the repositories for those two have been ported and actually work. So the first thing I did was like run like a text-based chat client and run screen, and then like show my friends like the output of cat proc CPU. I was like, look, I'm on a mainframe, guys. I'm super fun at parties. So anyway, if you looked in the list, Kubernetes is in there. And this is just a screenshot of, you can't read this, of the download page for the Kubernetes project. And there are S390X builds. So if you weren't familiar with what S390X is, it is a mainframe and Kubernetes builds for it. They also build for Power and ARM. So you can actually just go and download the client binaries and the server binaries directly from them. But like realistically, like who actually does this? Who is running Linux on the mainframe? So SUSE has an investment in it. There was this interesting article that was published in March about running the latest version of Kubernetes on SLES 12. So SUSE 12, which came out a few years ago, but running the latest version of Kubernetes because SUSE 12 is old and the newest version of Kubernetes did not come with it. And so the interesting thing about this article was they were like, this is how you do it for the mainframe. But you can also do it for x86 too. Like the instructions are pretty much the same because Linux is Linux. So SUSE has an investment here. You might have heard that IBM bought Red Hat. So of course there's a huge play here. And if it was up to like IBM marketing, this entire talk would be about OpenShift. But you get one slide. So this is a blog post that was announced by IBM, like I think it was last month, where they were talking about how IBM has pretty much gotten rid of a lot of their container efforts that we're doing internally and switched entirely to Kubernetes. And this includes Z. So OpenShift is being ported to Z. They're integrating it into the plan for like IBM Cloud Packs, which make like getting a lot of the IBM software much easier on OpenShift. Ubuntu has their CDK, the canonical distribution of Kubernetes. And so there's this Ubuntu on Big Iron blog. If you're interested in mainframes and Ubuntu and you haven't seen this blog, it is awesome. It's super technical. It's written by a guy at Canonical who used to work on mainframes and then came to Canonical and now works on mainframes again. But he posts tons of really technical articles. So he's talking about using Canonical's deployment technology to install Kubernetes on the mainframe. And he sent me over this slide. And so you see how you install it. So you've got your LPAR running on your mainframe. So, and then you install Ubuntu Server on the LPAR. So that's the logical partition. That's the space they have to install stuff on. Instead of using Docker, Canonical and Ubuntu is very invested in LXD. So they're using LXD as their container environment. And then you see all the familiar services from Kubernetes. You've got your SED and all your workers and everything. But this is pretty much what it looks like. And this is specifically for Z. Of course, the x86 version looks very similar, but it's not running on an LPAR. There's also a few consulting services that are doing Kubernetes on the mainframe. I'm going to say that I don't actually know how to say the name of this company because I only talk to them on email and like mailing lists and stuff. Yeah, oh, all right. But the great thing about these guys, they've been working with OpenShift Origin, and like they've been offering consulting services for that, and also being super active in the community. So they give away a bunch of their like PDF guides on how to install OpenShift Origin on Z, and they are also really active on there's a Linux mailing list for S390, and they're super active anytime anyone asks about Kubernetes. And when I was preparing for this talk, one of like the research things I did was reach out to the mailing list and say, hey, who's running Kubernetes, and tell me your stories. And they reached out and they were like, here's all our PDFs, and they're good folks. I also discovered ICU IT services out of the Netherlands, and the representative who got back to me from this company, they were saying that they're helping our customers integrate with traditional ZOS environments and new cloud environments, and that's what they're doing with Kubernetes. So they're taking Kubernetes and the entire ecosystem of software that they are compiling for Z or have already been compiled, and using that to help their customers modernize. But they're still using ZOS and other private environments. And the reason they all want to use this is the same reason we all want to use Kubernetes, right? They want to use containers. They want to use microservices. They want that orchestration, because once you get more than like a dozen containers, it's a giant mess. And they want access to the big ecosystem of services and partners in there. And as we heard from the one consulting service, like they want to integrate with the traditional ZOS environments. So they want to run their containerized workloads alongside all of their programs that are written in assembler and COBOL and like everything that actually runs their business and actually runs really well. And they want it close to their data. So they run Kubernetes on the mainframe that's sitting next to the other mainframe that's running ZOS, or on the same one, because you can mix like Linux and ZOS on the same mainframe, and then attach to the storage, so they have really fast access to any of the data that they want to get. So in the one example, like they want to be accessing DB2 on ZOS, or Oracle running on Linux on Z, and having their microservices on the same machine is a big deal. They're also really interested in leveraging the hardware crypto. We heard in the keynotes yesterday that like Intel's totally on board with doing end-to-end hardware crypto too. Like x86 is definitely getting there, but Mainframe's been doing it for quite some time. So like this end-to-end encryption thing is a really big deal for us, and the Mainframes actually do it really well. And one of the things that actually fell into our laps, it seems like, is blockchain. So I gave a history of Linux on Z talk back in July for a Linux users group in Philadelphia. And when I gave him my little talk abstract, I was like, here's what the mainframe does, really fast crypto. He's like, sounds like that would be really good for blockchain. I'm like, stop telling my story. But it turns out mainframes, like, they are super crazy fast for blockchain. So IBM created like this whole blockchain platform built around IBM Z. And so if you use some of like the stuff in IBM Cloud, some of that is backed by mainframes, because the onboard crypto makes it really fast to do all the blockchain stuff. Another thing that people tend to like it for is if they're going for some sort of hybrid cloud approach. So they want to run the same, say, Docker container across like a bunch of different environments. And so, when the next like meltdown or Spectre hits and their x86 machines take a performance dive, they can offload some of their workload to a different architecture. This is like the same story if you're talking about ARM or Power or any of these other architectures. It's becoming increasingly important to diversify your infrastructure if you actually need a lot of resiliency in your system. And like I also love geeking out over alternate architectures. I have like an Ultra Spark in my office. That's not running at the moment. I have to install BSD or something on it, but I've played with it a lot in the past. And my husband has a whole bunch of like MIPS boxes in the garage, and like, it's a big crazy place in my house. But like it's something that you should be considering when you're like, I want to get rid of the mainframe, but I'm like, but it's got all these great things, and it's a different architecture from this one that keeps having vulnerabilities. Not that it's immune to vulnerabilities, but x86 has been a huge hard target because of these specific issues that have been coming up these past few years. So I kind of wanted to wrap up and leave some time for questions that hopefully I can answer. I just started in April, be gentle. But some of my suggestions. So, coming back to our story, the new DevOps team came in, they couldn't complete their project because they still won't have the mainframe, they're very sad. But this is not actually a sad result. You are leveraging the strengths of Kubernetes and the strengths of your mainframe, and the point is not to be cool and modernize everything. The point is to deliver the business need to your customer. And if a mainframe is the thing that is delivering that need and handling your data and it's doing really well, and it has been for 30 years, there's actually no reason to change that. So one of the things you should do is when you start this modernization project and you're diving into Kubernetes is get the mainframe team out of hiding. Sometimes they won't like it because they feel like they're being replaced. Or they just are set in their ways. They haven't had to modernize. They've been doing the same thing for a long time. But including them in the process is really, really important. And so play to those strengths and integrate it into your plans. So consider the mainframe. What is it good for? What talent are we investing in our organization? Do we want to run a distributed storage operation, or do we just want to stick it on a big box that has 6 petabytes? And so work that into your plan. And there's also a project, there's the Open Mainframe project, part of the Linux Foundation. They've been putting out some really interesting software around ZOS. So there's a project called Zoe, ZOWE, which puts a consolidated API across a bunch of mainframe services. And so you're able to run there's a CLI client that you can run things against. And so you can run your Jenkins jobs against things in the mainframe, which is pretty cool because then you can just integrate it into a CI/CD pipeline. And you don't even need to change anything. I mean, you have to run Zoe, but you don't have to change things on the mainframe side itself. So that is my recommendation. And I want to thank you and leave it open for some questions. Yep.
So it's something related with IBM SSD secure service containers?
Yeah, so the question is about IBM secure service containers. So secure service containers are on Z, and those are things that we would run I think currently they're mostly just used for the HyperProtect services and the IBM private cloud that we have on Z. Yeah, I mean, so that it's all in the same family, yeah.
I heard that IBM is preparing Kubernetes style deployment for SSD in the future.
Yep, so I don't know what's public. What am I supposed to say? He might know. Okay, so Kubernetes is being ported to Z. And I'm pretty sure that that's what we're going to be basing the secure service containers on going forward. I don't know. All right, so we're saying 2Q for public cloud, 1Q for private for next year. So it's coming. And then we're also doing all the IBM cloud packs will then be on top of the Kubernetes stuff, OpenShift. Yeah. Yep.
Is there any capability for the LPARs to speak to each other, or once it goes to Kubernetes, it's just kind of out?
Yeah, so the LPARs don't talk to each other, so and then the Kubernetes sits up a really high level in the stack. So I don't think you would talk across LPARs in any special way. I think you would just use TCP at that point, I think. But
one of the benefits of the mainframe is it's small enough to know when you're in the same box, right? So you don't have to go all the way through TCP and down there and you just right? So there's a benefit in that. It is TCP.
yeah.
There are fast channels between LPARs.
Yeah.
I forget the names, hypersockets.
Hypersockets. Yeah.
Copy memory that between LPARs instead of going over the wire.
Yeah. All right. Thank you.